Hi guys, had a few people asking some questions about embeddings, so I thought it'd be much easier to make a video than it would be to try and explain over text. So let me just jump to my desktop. Here we go. So here's an example of when you might use embeddings. So if you think traditionally, this is how we used to approach everything really in terms of computers. So in fact, these can be websites for sake of argument. So let's say we were searching for the term book. And if you look through our possible websites, it's quite obvious that this one contains the word book. So it's really easy. You go, yep, this is the site that I'm going to return back. However, where things get more interesting is if I was to search for the term library. So library obviously isn't in any of these texts. We know as humans that books and libraries go hand in hand, but it's not the same thing. For a computer, it's looking for specifically the word library, the exact match, and it's not finding it. If we were searching for red books or something, the computer might be clever enough to go, oh, it doesn't appear in any of these results, but I can split it and I can go, oh, books is here, so maybe I'll do it. But where it gets interesting is with that search term library. So let me try and explain this in a more visual way. So this is a graph that we made for a previous project, and it's to do with personalities and things, but ultimately you can see it's a 3D chart. So this is vectors represented in three-dimensional space. So OpenAI's vectors actually are in 1,500 dimensions, but this is much easier to visualize because as humans we're quite good at doing 3D. So I've flipped it to a flat view, so this would be like a two-dimensional vector. But you can see that this would be x minus 1, that's x plus 1, and this would be y. I've got it around the wrong way I think, but this would be y plus 1 up here and y minus 1 down there. And you can see that stuff's been pulling in a direction. So if in our example earlier, this square here might have been book, and this square here might have been library, and then we can use a technique called cosine difference, which basically creates a sphere and finds the closest dots or other sources that relate to it. So whilst library might have book, it might also have like bookend, or it might have hardback or softback, and these are all words that are related, but they're not the same word. So I wouldn't find it with an exact match, but I would find it with this vector. It'd pull that way, and then I could find it. And obviously in 3D space, it's slightly more interesting because I could go this way slightly and slightly that way, and I'd ultimately find, so you can see there's a little cluster here that they've all brought out together. And for this particular project, there was obviously some interesting things. And when it comes to the OpenAI text embeddings, like I say, we're not very good at visualizing that 1,500 dimensional space, but they're pretty good at it because computers know what they're doing. But in this case, had I searched library, it would pull it in the same direction as this word book, and then it go, oh, this is actually like highly related, even though it doesn't have those matching words. And it's using powers like that you're able to get these similar matches and then do exactly what it is you're after. But anyway, I hope that explains what text embeddings are and vectors, and I hope you have a great day. I'll catch up with you soon.